So this is my Printrbot Metal Plus. I got it in October of 2015, so not quite a year ago, and I love it. It's been a fantastic printer. I've gotten to print lots of awesome things with it. My kids really enjoy being able to either download things or create their own ideas and actually be able to bring them out and print them. So it's been a fantastic printer. The problem that I have is that every now and then my hot end fails. And what's actually happening is that between the printer board down at the base of the printer and the Ubis ceramic hot end up here, there's some wires and those wires break. They move a lot with the print head and they just get flexed too much, and at some point somewhere in the wire there's a break. And that means that now the signal that, or the voltage that's going to heat up the hot end doesn't get there and it doesn't get hot, and so I can't extrude plastic anymore. And so I've already been through this once. Printrbot support sent me a replacement cable. This is actually the original one that I took out and I had cut it, so that's why it's cut there. But you can see that with the ends on it, it's kind of a hassle. I had to cut all these zip ties and pull it through the braiding and all that kind of stuff, but I did it. And this is, as I say, the old one. But even though I just replaced that within the past, probably 2 months, it's already broken again. And so anyhow, I'm going to use this as an opportunity to show you A, how I diagnose it, and then B, hopefully how I repair it. This time I'm not going to get a whole new wire. I'm just going to leave the existing ends that are in there and just replace the wire between and resolder on the ends, and hopefully that'll work. But anyhow, so that's what I'm about to do. Let's get started. So first, let's take a look at the problem. You can see that I've got Cura open here on my computer, and I've got the Printr Face UI open up. And I see that right now it sees that the extruder is at about 30 degrees Celsius and the bed is at about 34. And so just as an example, I'm going to go ahead and tell the bed to heat up to 70. And you'll see it start to climb up here. And I'll tell the extruder to heat up to 210. And so if you just keep an eye on these, you can see the extruder is in fact already heating up. It's now up to 36. It started at 34. The extruder just isn't budging. So that's the problem, is that even though I've told it to heat, it's not heating. And sure enough, if I touch it over here, it doesn't get hot. So there's some problem going on here with the extruder. So one of the ways that I can diagnose this is that I can actually disconnect the cable where it comes in to the hot end from the extruder. So this end is the extruder, the printer board end. It runs down through the cables down there. And then this is actually the leads that are coming out of the Ubis extruder hot end here. So it's these little black and red wires here. And again, those are the ones that I'm suspecting are broken somewhere inside. And so basically these two ends go off to the resistance element that's inside this Ubis hot end here. And we basically should get a voltage across these, and they heat up that resistor and cause the heat to happen. Actually, it's down here in the tip down here. But that Ubis hot end should have about 5 to 6 ohms of resistance. And I know that just from searching the forums. When I fixed this before on the old Printrbot community site, which they've unfortunately now decommissioned, there was a number of threads on this. But there's a Printrbot Talk or PB Talk, I forget. I'll put links to the forum post in there. But basically talks that this guy should be around 5, maybe 6, some odd ohms in there. And so I've got my multimeter here. I'm going to open this up, and it's a little tricky, but see if I can get these two leads in there. And measure up the resistance. And yep, sure enough, it's coming in right about 6 ohms. Okay, so it looks to me like my hot end itself is okay. So next, I need to diagnose these wires, and to do that, I got to get in to the bottom of the printer. So next, I got to flip the printer upside down so I can take the bottom off and get to the innards. So I'm going to go ahead and grab it here. I've got it all disconnected, and just carefully flip it upside down here. And now I basically just need to go around the sides. There's these screws. There's 4 on this side, 2 on the ends, and 4 on the other side. Go through and remove those. So let's get going. I'm using a Torx 8 screwdriver to get these out. So let me go taking it apart. All right. So I've got the bottom off now, and I can get in and get to the printer board. So next thing I want to do is make sure that when I connect it up to the computer and tell Cura to start heating up, or the Printerface UI to start heating up the extruder, that I'm actually getting 12 volts off that hot end connection. And that's basically this. So might be a little hard to see, but it's this little connection here. So I can go ahead and pull that off and make sure that I'm getting 12 volts off the printer board when I tell it to heat up. So that's what I'll try next. All right, so I've got the printer all flipped upside down and bottom off. We saw that before. And so this is the printer board in here. I've actually got it, got to be careful here, I've got it powered on. So in fact, let me power that off really quick. I should be paying attention there. But you see I've got the power supply hooked up. I've got the USB cable going off to my computer in here. And inside here, these black and red leads are the ones that ran down to the Ubis hot end down on the extruder. And so I want to actually disconnect this connector here. And so in fact, I'm going to go ahead and zoom in here on this camera here so you can see that a little bit better. So this connector, big fat one, is where the power is coming in from the power supply, and then right next to it, this little white one with the black and red leads coming into it, that's running off to the hot end, to the extruder. So I'm actually going to disconnect that here, just to kind of lean it back away and pull up. And so again, you can see here the red and black wires coming off of that, and those again run down to the extruder. And what I want to do then is go ahead and hook my meter up to those pins. So if I look at this, the black was here, that's ground. The red on the other side, that's the positive voltage. So let me get my test leads hooked up here. Switched out my multimeter test leads to these guys. All right, cool. And get this up where you can see it. Set it to VDC. All right. Turn on the printer, and you can actually see there is a little bit of a voltage there. But over on the computer then, I've got the Printerface UI open up, and I can see that the temperature, oops, let me reopen that. Got disconnected when I turned it off. And I can see that the extruder right now is sitting about 30 degrees. That's just from the ambient temp there. Let me go ahead and tell it to heat up to 210 and watch the voltmeter when I do this. Yep, sure enough, it's jumping up to 12 volts. So I can see that the printer board is in fact sending the voltage out through the connector that should be going down to the extruder down here and heating that up. It's not happening, and that means that somewhere between this end and the other end, I probably have a break in the wire again. So let's see if we can diagnose the wire. We'll do that next. So to test the continuity, I've made just another quick change, just put some little jumpers at the end of my little test leads here on my multimeter. And I've got this end of the wire that runs from the extruder, or sorry, to the extruder from the printer board. Right, remember there's the black and red leads on that. And then I've got this other end of it down here, which is where it actually hooks up to the hot end, on the extruder on the hot end. And again, there's the black and the red ends there. So my guess is that somewhere between these two ends, something has disconnected, right? And it could be, in fact, on the connectors themselves, or probably more likely in the wires in between. So I'm going to test that here. I'll hook up one end of my test lead. Actually, first, let's get my multimeter here just set to test continuity. There we go. So when the two ends touch, I should get a beep. All right. So we're going to plug one end to the red, into the connector there with the red. Down here into the connector with the red, and I'm getting a good beep. That means there's continuity. So let me switch this one over to black and switch this one over to black. No continuity. So it looks like I've got a break in my black wire somewhere. Well, that's a bummer, right? So anyhow, that certainly seems to have diagnosed it there. That appears to be my problem. There is a disconnect inside that wire. So that's what I want to do, is replace that wire. And again, the problem that I have here is that the wire runs all the way through the braiding, down in through zip ties and all that kind of stuff. So it's not fun, but certainly doable. And so that's going to be what I do next. All right. Well, so the next thing I want to do is actually start to loosen up these zip ties so that I can pull the wire out. But there are a lot of zip ties. And so the first thing I'm going to do is go through and take good pictures to make sure that I've got some documentation about how all this stuff should go back together. So I'm going to go through, take good reference pictures, so I've got those available. You see the braiding goes down through the hole there, and I'll just speed this up and you can watch me sort of document and get started. All right, so I got a bunch of these guys around, and see if I can get that turned where you can see that a little bit better. And so I need to cut these guys, and then again, just remember that they're there. I'm going to go ahead and put some loose ones back in place. Well, you know what? I bet I can get by without these loose ones. What the heck? We'll just cut and run here. Now, this one's actually tied inside. There's a little clip inside there, which is a real pain to get to. It's way down inside there. I'm going to see if I can get by without doing that one. And then, because that's probably the most painful one to get to. And then underneath it comes through this grommet, and then I've got these ties to undo too. So let me grab those. Being very careful not to cut anything else here. All right. All right, so I figure I should do actually one last test before I go to the trouble of pulling those wires through. And that's just make sure that the hot end really will heat up with good wires. So not that I would call these good wires, but I've made this beautifully safe arrangement of male, female, female, male jumpers here, etc. But basically, this down here is the connector coming out of the Ubis hot end. And if I look at how the connector would actually connect, I can see that the positive lead is on the inside and the ground lead is over here on the right. And so this guy's ground, this guy's positive, and I've just kind of rigged these here to now where they go up to where the hot end cable would actually connect, positive and ground up there. So the idea then is I ought to be able to go into Cura, and so you can see here on the computer, I've got Cura open with the Printerface UI, and I see that the extruder temp is currently at 31 degrees C. So let's give it a test here. Remember when I did this before with the original cable, this wouldn't heat, so I'm going to type in 210 and step off it, and I can basically just watch this number, 31, and we should see it go up. Woohoo, it's going up 32. And in fact, if I hold my finger over the tip here, it's already up in the 40s. And yes, I can definitely feel that heating up. All right, so life is good. It looks like that's really the problem. Again, it's the wires running between the printer board and the Ubis hot end up there. So the next thing I've got to do is create the twisted cable that's going to pull through here. And replace the existing wires that are in there. And so you could probably just manually twist this up. Just a quick little tip here, a handy way to kind of twist a pair of wires is to actually use your drill. So I'm just going to take these two wires here, tear off a little piece of duct tape. I'm going to tape one end of them down to my desk here. Try to make sure they're on pretty good. And then I'm going to take the other end and actually just chuck them up in a drill. Into the end of the drill there. I'm just running them right into where the bit would go. And chucking it up until the chuck grabs it. And now I can kind of pull tight on this just a little bit. And then as I slowly turn the drill, it gradually twists my wires up for me. Be careful not to overdo it. You don't need a ton of twist in this, but that's starting to look pretty good. And then I can go ahead and uncheck it. Oh, my battery kicked out. And there you go. And now I've got some twisted wire, and you can just let it unwind there a little bit to get rid of the kink in it. But there you go. Twisted wire pair. Cool. All right, and I went ahead and cut this to about 48 inches long. That's should be more than I have. I measured the original one, and it was about 43 or 45 or so, something like that. So that should give me plenty of room to make it through, and I can just bundle up the excess inside the Printrbot. So anyhow, that's how I made my wire. So I've rearranged here yet again. I've got this is the end coming through the braiding that should go to the Ubis, and then this is the end coming out of the bottom that should go to the Printrboard. And I've actually been trying, you might be able to tell here just as a little test ahead of time, I've been trying to tug on this and see if I could get it to pull through, and it's a little too tight. And I think it's, if you might recall, there were a couple of zip ties down inside here that are kind of difficult to get to. And I had originally opted not to cut them. I think I'm going to go ahead and cut those. I went ahead and again made sure that I've got pictures of those. So I've got them all documented here. But I'm going to jump in here and snip that zip tie. Again, being really careful. Try not to snip the braiding. And this one's the hardest one. So I'm going to be in the way of the camera here, like it or not. There we go. Got that one cut. Cool. All right, so my hope is that now things are loose enough that I ought to be able to, I can kind of pull this braiding out down here. Try to get a little bit of a straighter route. And I'm hoping I can kind of pull on one end. Oh, come on. Where are you at? There it is. So it's starting to move. All right, so before I get that going any further, I'm going to go ahead and cut a healthy end, healthy bit of length off this end. That should be enough. And obviously I've got everything disconnected here. And now I want to go ahead and test the ends of these here and make sure that the break isn't somewhere within there. So let me go ahead and just trim this down really quick. Cool. I'll grab my test meter here. Put it onto a continuity test. There we go. So red to red. Looks good. And black to black. Looks good. All right. So that means that I should know that this little piece of cable is good. And this is going to be what I solder my new wires back onto. So I'll set that aside. And now what I want to do is go ahead and get the length of cable that I twisted up. And I'm going to want to go ahead and attach these together here. And so I might as well just solder them to make sure that that's a good connection. So I'll take care of that. All right, so that soldering wasn't so much about electrical connection. It's more just about making sure that those are well attached. So I'm going to go ahead now and just add some electrical tape onto that. And again, this isn't about insulating or anything right now. It's just about giving me wires that I can pull through without having it come undone, because that would be a pain in the rear. All right. So at this point, I've got my new wire connected up to the old wire. So I ought to be able to go back to where I was pulling them before and start pulling again. I can see it going through. New wire. Let's see if we can get it to come all the way out for us. Come on, you can do it. Ah, there's another zip tie hidden in there, and it's hitting on the tape. Ha ha. All right, let's get rid of that guy. All right, so yep, the zip ties did have to all come out. That's just the way it is. There we go. All right, the new wires all the way through now. Got the new end coming out. Cool. So at this point, it's really just about getting these ends clipped off and soldered back on. So the same thing now. This is the other end. I'm going to go ahead and clip off a reasonable length of this. And this is my old wire. Same thing here, though. Let's strip off a little bit of this. Get my multimeter back out. Red to red. That looks good. How about black to black? Haha. So it would appear that my break is somewhere closer. And in fact, if I look, I can see that might have been a way for me to just fix this up front. It looks like it's, those zip ties might have been a little tight. I'm going to try clipping it off a lot closer. Now, you can also, of course, just buy replacement connectors, which I should have done. I had plenty of time. But in this case, I'm just going to try and reuse the connectors that I have. So this doesn't give me a lot of room to play with, but we'll strip them off closer here. There we go. Let's test those. Red to red we already knew was good, but what the heck, we'll test it again. Red to red is good. And how about black to black? Black to black is now good. All right. So my break was somewhere just in those last few inches, which I guess means I could have not replaced the entire thing. I might have been able to just pull some of the slack out. But that's the way it is. Already done. All right. So my next exercise is to get the ends soldered back onto the ends of the new wire. All right, so doing just a little bit of prep here. I've got the ends of the new wire stripped off. I went ahead and cut some heat shrink, and I've got them kind of staged. I've tinned the ends of the connectors, so those guys are all ready to go. And again, heat shrink and stuff over here on this end too. So let me go ahead and get started. Try and get this end connected. All right, that looks pretty good. The heat shrink and stuff up over that. And I went ahead and grabbed this one here just to add some extra protection, since it seems kind of like right in there where the bends were happening. So see if we can get them both up in there a little bit. All right, let's get the other end here. All right. Well, at that point, we should have new ends. We got the printer board end and the extruder end soldered up. Next test, we'll connect this back up and make sure it actually heats from the computer. All right, so I've got all the new cables hooked up. Here's the printer board side. I've got it soldered back up, connected. Down here's the extruder end. I've got it plugged back in where it needs to go. You can see the green shrink wrap kind of hiding down inside there. And over on the computer, I've got the printer UI open. It sees the extruder at 31 degrees C. So let's go ahead and type in 210, step off it. And again, on the Printer Face UI here, hopefully, pretty quickly here, we'll see it stepping up. Woohoo, it is. And I can touch it over here. Yep, starting to heat up. Cool. All right, starting to be able to feel it on the end. All right, woohoo! So, new cable works. Well, really, all that remains now is to tidy this stuff up, right? I undid all these zip ties, and so I've got to go get that all redone. Let me actually first, before I do something stupid, turn this off and disconnect everything. All right, and just like taking them off was not an easy thing to discuss, I'm just going to go do this. I'll probably speed this up, but I'm just going to try and get things tidied and get all these zip ties back in place. So here goes. Actually, one other comment. Remember, I had taken the time ahead of time to go in and take a bunch of pictures. So now is going to be when I go back and refer to those. So I can look at that and go, oh yeah, that's right. That's how all that stuff was connected. Okay, so here we go, digging in. I'm going to take care not to over tighten, because I think that might have been part of my problem last time, or just in general, is that these are getting too tight and breaking some of those leads. All right, well, hopefully that did it. Now, I still need to button up the bottom, but I learned after years of having to reopen computers after I supposedly fixed them that I should go ahead and test it one more time here before I button up the case. So back over here in Cura, let me go ahead and open up the printer UI. Looking good. It looks like the extruder is still cooling down from the last time, but at least that means the thermistor is reading correctly, or at least getting a value. So let's give it a test. We're going to put in 210, step off it, and we want to see this extruder temp going up. Woohoo! It's going up. Good deal. All right, I'm going to quickly bump it back down here because I don't want it to get too hot on me. But looks like that's working for me. So last piece, let me button this up and actually see if we can try move it around, do a little test print. All right, I got all my screws back. I got my torque state screwdriver there. Let me go ahead and turn this off and just get this all disconnected. And again, carefully flip this guy back upside down. Good. All right. My bottom back. And you need to make sure that the notch in the bottom lines up with where the cable comes out. And this kind of sits down inside, so it's actually a little bit of a pain to get lined up. You do have this finger hole here to use, so I like to get just one on each of the corners started. Now, the one other reason to not button this up yet is if in all your mechanicians you fried the firmware on your printer board, in which case you'd still need this open to reflash the Printrboard firmware. But mine seemed to be working okay. It was detecting correctly. The commands were going. So I don't think I'm going to have to reset my firmware. But if you did, you'd need to be able to get to some jumpers in the reset button that are on the Printrboard itself. So it could actually have been a better idea for me to actually do a test print with this before I buttoned it up. And now that I've said that, that probably means my firmware is going to fail. But we'll go ahead and button it up and give it a go. All right, buttoned up. Let's get it reconnected, hook in some filament, give it a test print. All right, so I've got everything reconnected. I've got a spool ready to go, but I've got to heat the extruder up before I can spool that through. So over here on the computer, I've got Cura open, and I've just loaded up the Printrbot default 3mm box there, the sort of the initial test print. I'm going to be printing straight onto Kapton. In the past, I've had some issues with that, but after the last go around, when I was using this last, I got to where I could, just by making sure it was nice and clean, I could print directly on the Kapton. And sometimes having a brim on there would help. So in fact, maybe I will come in here and add a little bit of a brim in. It's got 40 lines. Maybe I don't need that much. Maybe we knock it down a little bit. And the brim just helped sort of with that platform adhesion there, as the name would indicate. So, all right. So with that said, let's first of all come in here to the print UI. That over here on this screen. All right, that all looks good. Now, you may also be able to tell on my bed that I have driven the extruder into the bed a few times, and it's even the last time after I got it fixed, it looked like it was working, and then all of a sudden it dug into the bed on one of its moves. So I'm hoping I don't have to reset the firmware and recalibrate this thing again. We're going to give it a test though. So first of all, let me go ahead and X home. All right, that looks good. How about Y home? Put the cable down. All right, Z home. All right, well, so far everything's looking good. I'm going to go ahead and heat the bed up to 70, knock the extruder up to 210, and we'll just let these guys climb. So let me go ahead and raise Z up. All right, well, it should be getting hot enough now. Let's see if we can get some filament pushing through this guy. There's some old wood filament in there before. Looks like the silver's starting to come out. So it's definitely getting hot. That's a good sign. All right. Well, and let's try extruding. That's all looking pretty good. All right. Well, no time like the present, guys. Let's print. All right. Well, looks like it worked. I've got my part. Pull the brim off. And it printed. I had some issues there with the brim not wanting to stick, but I'll trim a little more of that brim off. But there you go. I've got my box. That must mean the extruder is working again. Woohoo! So there you go. It's an easy to understand problem, but I wouldn't call it an easy fix. It's not difficult or logically. I mean, you can understand it. There's some broken wires, but just the mechanics of getting through and pulling the wires through the braiding and getting the connectors and all that kind of stuff. It's kind of a pain in the rear. I'm expecting this to happen again, since it's already happened to me twice and I haven't even had it for a year. And if it happens again, I think I'm going to think maybe the routing of the cables. I've heard of other people laying down sort of different cable tracks or other solutions there as well. So should this happen again, I'm going to revisit that. But hopefully, if you're having the same problem as me, this helped you out. And let's get printing.